today we are going to be looking at determinants of matrix. This is a series of our lessons in matrix. We have been able to define what matrix are, the additions and subtractions of matrix, the order of matrix. We have discussed multiplications of matrix as well as scalar multiplications of matrix. So in today's class, we are going to be looking at intensively on determinants of matrix. So I want you to keep abreast with me as I walk you through this part of knowledge. Let's go. So suppose A is a matrix defined by A11, A12, A21, and A22. A is a matrix defined by A11, A21, and A22. Then the determinants of matrix A, which is designated as delta A, or a small triangle called determinants of a square matrix, such as this, is given as A11 times A22 minus A12 times A21. So this is a very simple expression for a 2 by 2 matrix. 2 by 2 matrix. However, when we talk of determinants of a square matrix that exceeds a 2 by 2 matrix, such as a 3 by 3 matrix, we have to consider the minor determinants and as well the cofactor of each of the elements in the matrix before we can talk of the determinants of the matrix. So just keep abreast with me while I introduce you to the core subject of determinants of 3 by 3 matrix. If we have matrix A equal to A11, A12, A13, A21, A22, A23, and we have A31, A32, and A33. This is a 3 by 3 matrix. It will be interesting to note that by deleting the rows and column of a particular element of a matrix, a minor is established. The minor of this matrix A11 is those elements that are formed, or another matrix, okay, that is formed by deleting the rows and columns of A11. What do I mean? The minor of A11 here, for A11 minor, is equal to this. Because when we delete the rows and columns of A11, what remains is A22, A3, A23, A32, and A33. So this is the minor of this matrix, okay? However, the minor for the matrix A12 is also given as A12 is equal to delete the row of A12 and the column of A12. So we are going to have A21. So if you delete the row which A12 belongs to and the column which A12 belongs to, you are going to have A21, A23, A31 and A33. So this is the idea of the minor of matrix. Therefore, to obtain the cofactor of a matrix, which is a very important factor for the determination of the determinants of the matrix, this minor at how to find the cofactor of matrix in the next few minutes. Therefore, if we assign capital A13 as the minor determinant of A13, we have this as A21, A22, A31 and A32. This is done by eliminating the rows and the columns associated with A13. If we keep abreast with this pattern, we will find out that we can obtain the minor determinant of each of the elements of which matrix A is defined by. So, by so doing, we can now establish our determinant to be equal to the cofactor of each of the elements in the first row multiplied by the minus of the elements in the first row multiplied by the minor of the elements in the first row. We are not stopping there. For you to do this appropriately, you have to assign positive or a negative sign to each of these minors. This establishes the cofactor of the element. How do you do that? Recall that A is defined by Ij, and this is equal to Aij, that is small letter Aij. This means that every element in a matrix is defined by the row elements and the column elements. If the sum of the designated address of the element is an even number, assign a positive sign. And if the sum of the address of the element is an odd number, assign a negative sign. What do I mean? In matrix A equal to A11, A12, A13, A21, A22, A23, and A31, A32, A33. The cell address for element A11 is equal to I plus j, and this is equal to 1 plus 1. 1 plus 1 is equal to 2. Therefore, since we have an even number as the cell address for A11, we assign a positive sign. For for A12, we have this as I plus J equal to 1 plus 2 equal to 3. Therefore, is an odd number. We are going to assign a negative sign. The same thing happens to A13, which is equal to I plus J equal to 1 plus 3 equal to 4. This is an even number, therefore we are going to assign a positive sign. We can continue in the same pattern. The sign of the cofactors will be 1 minus, plus minus, plus minus, plus minus, plus minus, and plus. This can be used to determine the sign of the cofactors. Give me A11 times C11, D11, okay, then plus A12 times C12 plus A13 times C13. Now we are going to take a few examples on this.